The last chapter of, or the last section of chapter 1.8 is pretty easy for you guys. So I think that you guys have been doing this really since elementary school. So when you hear the words perimeter, area, circumference, I think you kind of understand what this is. But we're going to do some trickier ones towards the end. So the first thing we're talking about is a square. So a square I usually label with S's, but my S's look like 5s. So one of my students told me to use the little cursive S's one time, and I was like, oh, that's brilliant. So my perimeter would be S plus S plus S plus S. So it ends up being 4S. And my area is going to be like my length times my width, right, which is S times S. So we write S squared. So a rectangle, you can use length and width, or you can use base and height. It doesn't matter. So the perimeter ends up being length plus width plus length plus width, or 2L plus 2W. And your area ends up being the length times the width. Okay, and again, you could have B's and H's there. So the next one, a triangle. So our perimeter is just adding up the different sides. So maybe this is A, well, I'll call that one B for base. B, A, and C. So you would just say the A added to the B added to the C, whatever those side lengths are. But our area ends up being 1/2 base times height. Okay, and if you think about why that is, so I can kind of draw a little sketch here. If I extended this up, whoops, I always do that where it moves. If I extend this up to the top of the triangle, and I extend that up to the top of the triangle, oops, I'm still kind of moving it. Then I draw this line in. Sorry, doesn't like me being up here at the top. Extend that one in. I know it's not perfectly straight, but my pen's not working there. What's created is like a rectangle. In that rectangle, we have a triangle here that ends up being the same as this triangle over here. And we have a triangle here that ends up being the same as this triangle here. So it ends up being half of what our base times our height, like the area of the rectangle would have been. So that's where that formula comes from. So it's 1/2 base times the height. All right, so the next thing is a circle. So a circle has what we call a circumference and an area. So the circumference is the distance all the way around the circle. Okay, so our circumference ends up being pi times the diameter. Okay, so for many, many years, people tried to figure out what pi was. They tried to find approximations for pi. So most people knew that it was somewhere around 3. But they were trying to find this number that the diameter had been multiplied by. How many times, like if I had a rope that went across here, how many times would you need this rope to go around here? And it ends up being a little bit more than 3, which was pi times diameter. So you might also see that in another way. Well, what is diameter? Diameter is twice the radius, right? So here's our radius, and here's the diameter. So you might also see 2 times pi times r, because 2r is the diameter. All right, so that's hopefully not confused with the area. I know everybody, when they are in geometry, they always get these confused. This should be pi times r squared. Okay, so the area is pi times r squared. So pi is the ratio of the circle's circumference to its diameter. So if I take the circumference and I divide by the diameter, I end up getting pi. All right, so number 1, so it says find the perimeter and area of a square with a side length of 12 inches. So if I have a square, and I know one of the sides is 12, that means all the other sides are 12. So my perimeter is going to be 4 times 12, which is 48. And my area is going to be 12 times 12, which is 144. So in geometry, we're going to be careful. We're going to use units. So originally I had inches. So imagine I had a piece of string and I pulled it all the way around. My units would still be inches, right? I would say 12 plus 12 plus 12 plus 12. So 4 of them ends up being 48 inches. But area is the one that involves a square. So it's going to be 144 square inches. And what that means is if I drew a bunch of lines in here so that I had 12 little sticks here, and then I had 12 little sticks here. All of these little tiny pieces, all those little squares, are 1 inch by 1 inch, so they are square inches. That's literally what I mean, square inches. So that's where the square inches comes from. And that also helps you keep track of your area of a circle and the circumference of a circle. The area is the one with the square. So the units are, you know, things like inches squared, feet squared. So that's the one that has to have that square. Okay, so number 2. So it says find the perimeter and area of a rectangle with a length of 20 inches and a width of 15 inches. So if I have 20 by 15, you can draw it all the way around if you want to. If you add up the 20 plus 15 plus another 20 plus 15, I'm going to have 40 plus 30, so I have 70 inches. And my area is 20 times 15, which is 300 square inches. All right, so it says find the area and the circumference of a circle with a diameter of 10 centimeters. So my area is going to be my pi times r squared. So what we're saying is we have a circle, and going across is 10. So that means my radius is 5 and 5, right? So my area is going to be pi times 5 squared. So it's going to be whatever 25 pi is. So this is what we would call the exact answer. So sometimes, you know, online homework might ask for the exact answer. And sometimes it might say round to 3 decimal places, so to the 1,000th, or it might say round to the 10th. So when we do this, we want to use our pi button. So we're not using 3.14 anymore. We're bigger. We're better than that, right? So we're going to do 25, and we're going to do second. And the pi button is over here. It's where that little arrow up button is. So when I hit it, it says 25 pi. So I'm going to say 78.3 decimals. So 5, it would be 3, but then this 9 would round up. So we're going to say 540. So 78.540. All right, and then the same thing for the circumference. The circumference is 2 times pi times r. So it was 10 pi. And I do the little approximation there, so it shows that I've rounded, and that's going to be 31.416 if I do 3 decimals. Okay, and our units for the area are square units. Areas are always something squared. And the circumference is a length, so our length is centimeters. All right, hopefully this is all pretty easy to you. You kind of remember this stuff. All right, so the next one says find the area and perimeter of the triangle defined by -2, 3 is A. B is 0, 7. And C is 3, 3. So this is a tricky question. Oh, hang on. Now I see why it's tricky. I was like, man, why did I make this question so hard? A is actually, I didn't draw my A in the right spot, did I? So A should be -2, 3. Okay, that makes it better. We like it to be like straight across because then we can easily tell that the height is right here. So there are other ways, especially like at the end of geometry, we'll learn other ways to find the area of something that look like that. Okay, so let's find the area first. So our base is 1, 2, 3, 4, 5 units, and our height is 1, 2, 3, 4 units. So the area of this triangle is 1/2 base times height. So it's going to be 10. And I don't have any units, so I'm going to write units squared to show that it's an area. And our perimeter is going to be all of these lengths added together. So we have one of them, we have 5. But I need to find this length here, so I could use the fact that this is 2 and this is 4. So if I wanted to find that right there, I'd say 2 squared plus 4 squared equals c squared. or I could use the distance formula, which really is the same as the Pythagorean theorem. So I get 4 plus 16 is 20. So C is the square root of 20. Now if I want to find this other length, same idea. I have 3 units along here, and I have 4 units here. So if I say 3 squared plus 4 squared equals C squared, or let's call it something else, so D squared maybe. I get 9 plus 16 is 25 equals D squared, so D is equal to 5. So this is actually a common right triangle. You'll see this a lot in geometry. It's called a 3, 4, 5 right triangle. It's a common Pythagorean triple, so it's a good one to know. So these are all nice, nice whole numbers. So my perimeter then, if I write the exact form, it's the square root of 20 added to 5 added to another 5. So that 5 and this 5 and the square root of 20. So it's actually a nice isosceles triangle. So two of the sides are the same. So we'd write 10 plus the square root of 20. Now square root of 20 breaks down. So it breaks into 10 and 2, 5 and 2. So we have 2 2's. So the exact answer would be 10 plus 2 root 5. And if I wanted to find a decimal approximation, I could put it in my calculator. So 10 plus 2 root 5 ends up being 14.472. And that would just be plain units because it's just a length. It's not units squared. So it's not like little squares filling the space, right? All right. Number 1, so it says the area of a rectangle is 64 square meters. The length is 4 times the width. So let's make this the W, and this is 4W is equal to our length. So find the dimensions of the rectangle. So we know our area is our length times our width. So our area is 64. The length was 4W, and our width was W. So when I multiply those, I get 4W squared equals 64. I divide by 4. I get 16 equals W squared. And I take the square root, so I get W is equal to 4. So that means that this rectangle is 4, and then 4 times that is 16. So our dimensions, I'm sure you've heard people say like a 2 by 4, a 3 by 4. We write it as a 4 by 16, and these are in meters. And it doesn't matter which one you put first, so you can put the length first or the width, it doesn't matter. So those are our dimensions. All right, number 2, so you're putting a fence around a rectangular garden with a length of 15 feet and a width of 8. What is the length of the fence you'll need? So is this area or is it perimeter? So in this case, it's the perimeter, right? But if I had a question and I asked for the amount of like grass seed that you needed to purchase, that would be an area, right? So there's different questions will require different things. So we're trying to find the perimeter. So it's going to be 2 times 15 added to 2 times 8. So 30 plus 16 is 46. So it's going to be 46 feet. Okay, this one's a little tricky. So we have a 9 by 12 inch painting. And it says you would like to mat the painting before purchasing a frame. You would like a 3-inch border around the painting. So we want 3 inches to be the mat. So kind of like that piece of poster board, cardboard material to go around. So I'm going to be kind of careful where I draw my 9 and my 12 because I don't want to get confused. So I'm going to draw them on the inside here. And I'm adding 3 inches here and here, but also on the top and the left-hand side as well. So when I talk about this whole distance, it was 9 originally, but I've added 3 inches to both sides. So 9 plus 3 plus 3 is going to be 15. And when I talk about this whole distance, it was 12 originally, but I'm adding 3 inches here and 3 inches here. So it's going to be 12 plus 3 plus 3, so it's going to be 18. So the frame that you should purchase is a 15-inch by 18-inch frame. Okay, so we have this type of question in math a lot of times. So sometimes we'll say, what is the area of the final frame? Or what is the dimensions that need to, for the mat, if you need to purchase a frame that's this size? So there's lots of ways that we can change this around. Okay, so number 4. So the Pantheon is a building in Rome, which was originally built for the 7 Roman deities of the 7 planets. The building has a large dome that is 43.3 meters in diameter. So this is kind of an ancient painting here. So if you look at this painting, it shows the Pantheon. So what is the circumference of the covered floor? What is the area? So we have this big dome on top, and that dome is 43.3 meters in diameter. So our radius is going to be half of that. So if I take my 43.3 and I divide by 2, I get 21.65. So I divided by 2. So the circumference is 2 times pi times r, or pi d. So if you just wanted to do your 43.3 times pi, you can round. So let's say I want 3 decimals. So when in doubt, do 3 decimals, because that's pretty common in math class to use 3 decimals. AP Calculus requires that. So we're going to say 136.031 meters. And then our area is going to be pi times r squared. So it's pi times that 21.65 squared. So do your 21.65 first and square it on your calculator, and then do multiply by pi. So I'll use approximately. So that is going to be 1472.535 square meters. It's a really huge room. It's really cool, so you guys will have to see it someday. I saw it with one of my January term classes. All right, so find the areas of the irregular shapes. These are kind of my favorite questions, so I'm sure that you will definitely have some of these on your test. So really you need to think about how to break things apart. So you could break it apart here, or you could have broken it apart with these 2 lines. But think about how to create different shapes here. So if we had 6 going across and we knew this was 3, then this is also going to be 3. So same thing here, this is 3 and this is 3. So the area of this big piece is 3 by 11, so it's 33. The area of this smaller one is 3 by 3, so it's 9. And the area of this one is 3 by 3, so it's also 9. So the area of the whole thing is 33 plus 9 plus 9. So 33 plus 18. So it's 51 square centimeters. So what that means is if we had these little bitty squares that were 1 by 1 centimeters, we would be able to fit 51 of them in there. All right, so the next one. So this is going to be a rectangle and a semicircle. So this is half of a circle. So its area is going to be 1/2 of the pi r squared. So its area is 1/2 times pi, and your radius is 7, so 7 squared. You guys see the radius is halfway here, 7. So let's find the exact answer, and then at the end we'll round it as well. So I do my 7 squared, which is 49, and then I divide by 2. So this area is 49 over 2 pi, or you could even find 49 over 2 is 24.5 pi. Now the area of this rectangle is 10 by 14. Well, that's going to be 140, right? So my total area is that 49 over 2 pi added to 140. That would be the exact answer. So it'd be this, and it'd be in millimeters squared. So if you wanted an approximation, you would do your 49 over 2 times pi, and then add that 140 at the end. So check on your calculator. You should get 216.969 millimeters squared. So usually I'm not too picky on those compound ones where there's like one thing has a pi and one thing doesn't have a pi. A lot of times I'll just say round to the nearest thousandth, like round to 3 decimals. But for those of you going into, eventually taking things like AP Calc or advanced mathematics. Like, you should really be as precise as possible. I always say that you guys are building the bridges someday, and we want you to build bridges correctly. So we never know what kind of career you're going to go into. All right, so this one. So I'm going to break it apart. So I had 12. So it looks like 6 and 6. And this was 8 centimeters here. So it's 4 and 4. And then if we had 3 and the whole thing's 6, that's also going to be 3. And then we're going to have 3 and 3. So we got lots of pieces going on. So let's start with the big rectangle down here. And you could break it into lots of different pieces. But that big rectangle is going to be 4 by 12, which is 48. And then our area of the triangle, let me just do this whole big triangle all together, is 1/2. Base was 6, height is 4. So do you guys see how this distance here is 6? So it's going to be 12. So my total area is 48 plus 12, so it's 60 square centimeters. Okay, so hopefully that all makes sense. I believe that's the end of that section.